Hey everyone. This lesson is called the sine law, and this is following all of the right angles triangle trigonometry. Now, the question today is, well, what if the triangle we're trying to measure is not right angled? And in that case, we have to use the sine law. So before we get going here, our learning goal for today is that we want to be able to use the sine law to solve problems involving non-right triangles. So now before we actually jump into the sine law and actually doing some calculations here, I want to show you why the sine law actually exists. Like, I don't want to give you a formula and just have you memorize it. I kind of want to explain why this thing is the way it is. So consider the triangle we have here, ABC, right? Triangle ABC. And often on triangles, what we do is, if this is angle A, on the opposite side there, right, we have side A. And with angles, we identify angles with capital letters. And with the side length, we use the lowercase letters. So you'll notice that for B and side B. And you'll also notice that for C and side C. Okay, so consider the scalene triangle ABC, and what I've done here is I've put in this altitude like that, and I called it H, meaning like height. It's the vertical height, and we know it's the vertical height because height and the height meets the base at 90 degrees. So what we now have are two right triangles. So for the first portion of this, we're going to focus on the left side here, the left right triangle here. So let's consider angle B right over here, okay? We could say that, sine of angle B equals opposite over hypotenuse, all right? So we're basically focusing right here and also on this left triangle. So the sine of B equals opposite over hypotenuse. So in this left-right triangle, we have H as our opposite side and C as our hypotenuse, of course, because we do know that if that's 90, then this is also 90. So we have sine B equals H over C. So what we want to do here is isolate for H, meaning we're going to multiply each side of this thing by C. And what happens is we have C times sine of B on the left, and on the right-hand side, the denominator C and the multiplying C cancel each other out. So what we're left with is C times sine of B equals H. Okay. Now what I want to do is focus our attention to the right-hand side, or this right triangle. We're going to again focus on this acute angle down here, angle C. And what we're going to do is set up the sine ratio for angle C. So as you know, sine of C equals opposite over hypotenuse. And in this particular triangle, this right triangle on the right-hand side, H is the opposite, B is the hypotenuse. So we end up with sine of angle C equals H over B. And again, what we want to do here is isolate for H. So we're going to multiply each side of the equation by the denominator of B, and this B cancels with the denominator B, and we're just left with B times the sine of C equals H. So essentially what we've done here is we've isolated, we've solved for H, the side length H, two different times. We basically have two representations of the same thing, right? H is C times sine of B, right? We know that from here. And also H is B times the sine of C. So we basically have two equations for H. We have this one here, which is H equals C times sine of B, and this one here, which is H equals B times sine of C. Now, before we go any further, I want to bring your attention down here. We can use the logic statement here, and the logic statement is this. Now, it's going to sound a little crazy, but hear me out. It says, if this is that, and this is something else, then that is something else. And I know, it sounds a little wild here, but mathematically, I think we might see this a lot better mathematically. It's this. if we know that P is equal to Q, right? And then also P is equal to R, then that means Q must be also equal to R. So maybe take a moment here and really try your best to digest that. It does make sense, but you really just got to think about it. So, going back to the right-hand side here, we have two equations for H, right? C times sine of B, and also B times sine of C. It says to continue, since these equations are literally both H, then what we can say is that C times sine of B must be equal to B times sine of C because they're both H. So that's what we say here. C times sine of B must be equal to B times sine of C. Now, what we can do here is sort of rearrange the equation. And that rearrange business, what I got, whoops, sorry, let me get rid of these guys. What we mean by that is, if you have, let's bring this down here. If we have C times sine of B, and we're saying that equals B times the sine of C, what we're going to do here is this. We're going to divide this, each side here by C. We're going to keep isolating. Now this C cancels with that C. So truly what we have left here is that the sine of B equals B times the sine of angle C divided by side length C. Okay, great. Now we want to get rid of this B from the numerator. So we're going to divide this side by B and also divide that side by B. And what happens is on the right side the B's cancel out and we are left with the sine of B divided by B equals the sine of angle C divided by side C. And that, ladies and gentlemen, is the sine law. And this is also true, I don't have it written here because we just worked with angle B and angle C, but this is also true for sine A over A. So the sine of an angle divided by its opposite side length, all the ratios for that are equal in every single triangle. So this is pretty much the sine law. Here it is. Now, if this slide kind of didn't really make a ton of sense, that's not the end of the world here. I just really wanted to show you the theory behind this, and I'm not just pulling this out of a hat. Someone down the line mathematically proved this, and that's why we're able to use the sine law today. Now, the sine law, it states that in any acute triangle, so basically in any non-right triangle, the ratio of each side to the sine of its opposite angle are equal to one another. That is the sine law, so pretty much in words. And again, I want to reiterate this. Whenever we're talking about an angle, all right, angle A, angle B, angle C, we use these capital letters. And then when we're talking about the side lengths, right, based on angle A, we know that directly across from angle A, right, like angle A opens up and creates side A. And when we're talking about sides, we use these lowercase letters. Same thing for angle B. Angle B, it opens up and creates this side B. And same thing for angle C. Like angle C opens up at a particular angle and it creates side C. Now, the sine law is, the ratio of each side to the sine of its opposite angle. Like those ratios are equal to one another. Now, when we're solving for side lengths, we often use this as the sine law. And the reason why we use this is because if we are solving for a side, it's really ideal to have the missing side length as the numerator. As we know from similar triangles, or even from SOHCAHTOA, which has been the past couple of days, when the unknown variable is at the denominator, it requires us to just flip everything anyway. So we might as well do that from the beginning with the sine law to make our life a little bit easier. Now, when you're solving for an angle, we're going to put the angles on the top here, right? The capitals, right? And that's sine A over A, right? All these capital letters here represent the angles. So when we're solving for an angle, we put the angles on top. And you'll notice these are the exact same thing, just flipped. And we remember maybe from similar triangles that, yeah, we're allowed to flip ratios like that. Okay, now that we have the sine law, we kind of know where it came from. We kind of understand the mechanics of any acute triangle, meaning the capital letter A is the angle, the lowercase letter a across from that angle A represents the side length. Let's jump into an actual example and start solving some things here. Okay, it says here, given triangle ABC, so here's triangle ABC right here, of course, find the lengths of sides A and B and to 1 decimal place, and usually 1 decimal place is exactly where we want to be for pretty much the unit. So if you're a steps person, we got some steps here, and don't forget, just again, it's kind of like similar triangles. We need to have that one complete ratio and one other ratio with only one unknown to be able to move forward. And this is the ratio that in similar triangles I often put a heart around because we love it. We totally love it. It says here, write out the sine law equation for the triangle. Now, since we're looking for sides, so you might want to fill in that blank. Since we're looking for side lengths, we want to put the side lengths on the top. So if we're going back here, we're going to be using this sine law right here. So we're going to go ahead and set it up. Oh, it's not working for me. Oh, there it goes. Okay, great. So we'll have A over sine A equals B over sine B equals C over sine of C. The next part here tells us, okay, use that sine law and substitute the values that you know. And if we have a look at our triangle, we have angle A, right, which is capital A. We do not have lowercase a, unfortunately. Actually, that's what we're solving for. We have angle B, right? Angle B is 65 degrees, but we don't have side length B, but that's okay. And lastly, we have angle C, and we do have side C. So let's go ahead and set that up. Let's fill in these blanks here. So we have A over sine of 45, which equals B over sine of 65, which equals 9 over sine of 70. And you notice that there is one complete ratio, which is exactly what we needed, and it's this one right here. So this completed ratio, the 9 over sine of 70, is going to help us solve for both side length A and side length B. Now, in the sine law, you know the sine law is super applicable when you have an angle and its opposite side. That right there is like a huge indication of, yes, sine law is going to work here. So we're going to set up the usable equations. So I believe on this left-hand side here, right over here, I'm going to solve for side A. So that means that we're going to have to grab the ratio with A in it, and then also the ratio that we love, the one that's completed. So we're going to set them equal to one another over here. So you may even want to put a little title, solve A, or lowercase a. I don't know. I like to keep things organized, and so do you, I bet. So we have this. Now, we have to solve for A. In that case, we have to isolate A. Currently, we notice that A is dividing by sine of 45. So what we have to do here is multiply each side of the ratio by sine 45. So we get A equals, well, 9 over 70 times the sine of 45. And the reason why we can write it like that is because, yeah, sure, we multiplied this side by sine 45 and also that side by sine of 45. And on the left-hand side, as you know, sine 45 cancels with sine 45 like that. And this is what we're left with. Now, the reason why I didn't write it fully is because of the sake of space and things like that. But now we can jump in right pretty much to our calculator. You can do this calculation in one shot in your calculator. It's just I really need you to be careful here. The way I'm going to type it in is exactly as you see it. I'm going to start off with my calculator. So pull out your calculator, make sure you got one in your hand. And here we go. We're going to start with an open bracket. And then we're going to put 9. Now I'm going to use the divide by symbol, like the old school divide by symbol. This one, this guy right here. So we have open bracket 9 divided by sine of 70. And then remember, depending on your calculator, you might have to close up that 70. And now we're going to close it all up again. So you might have a double bracket at the end of there based on the function of your calculator. Next, we're going to start a new open bracket and then type in sine of 45, close the 45 off, and then close the whole bracket. And we press equals, and we get something like 6.77. So that rounds to one decimal place as 6.8. And maybe we could even type in here units, because there are no units, so we might as well just put units. Now, at this point, I really need you to type it into your calculator and make sure you're getting the same answer as I am. If you might not be getting the same answer as me, you must double check your calculator and ensure that, well, one, it's in degree mode. It's got that capital D, or it might say DEG on the top of the display, and that's what we want. What we don't want is grad or rad. You know, we'll save that for the future, but for this one, make sure it's in degree mode. Now, if it is in degree mode and you still might have gotten the wrong answer, I really want you to look at how you type that in. I want you to double check it because it should certainly work. So if you are having problems with that, maybe check in with a friend or maybe use one of my calculators if you wish. Okay, now we're going to solve, we're going to solve for B over here. Now, if we're going to solve for the side length B, we're going to need that complete ratio with the heart around, and we're going to set it equal to the ratio that has B in it. Notice that B here is the only unknown. So now we got to isolate for B, meaning we're going to multiply each side of the equation by sine of 65. On the right-hand side, it cancels out, and on the left-hand side, it's just multiplying by sine of 65. So very similar, what you're going to do here is type it in exactly as you see it, using the brackets, being very cautious here, perhaps even using the old school divide by button for that fraction. And you type it in. I'm going to type it in here. So bracket, sine, 65, close the 65, and then close the whole thing. Open a new bracket, 9 divided by sine of 70, close it all off, equals, I get 8.68, and then it continues. So 8.68 can round to 8.7, and maybe we should put the word units at the end of there. So yeah, that's pretty much it. A, we got 6.8 units, and for B, we have 8.7 units. Look at that. That is awesome. So that is solving for side lengths. If you want to put a little title up at the top here, solving for side lengths, we're using the sine law. Again, I really want to reiterate this. I know I still have it highlighted here, but we know the sine law is super applicable when you have like capital C and little c. Like essentially when you have an angle and its opposite side. So it looks something like this. When you have that, that's how you know that you're going to have some sort of usable ratio. Okay, we're moving on here to the last slide. We have a new triangle. It's triangle ABC. They want us to find the measures of angle A and also angle C. Okay, so if you look at our triangle ABC, notice that we have angle B, and that's pretty much it. And then we have side A, so notice how this one's not labeled, so we should label it. This is little a, and we know it's little a because it's across from that angle A, right? We know this is angle B, so this side length must be B. And lastly, this is angle C, and this must be side length C. So at a first glance, kind of consider what I was talking about in the previous slide with this action going on here with the angle and its opposite side. If you look closely at this new triangle ABC, you might notice that we do have angle B and its opposite side. So that is a huge indication that sine b over b is going to be the usable ratio, or the completed ratio. So if you're a steps person, we got these for you here. It says write out the sine law equation for the triangle. Now since we're looking for angles, we're going to put the angles on top. So we're going to rewrite it like this. Sine of a over a equals sine of b over b, which equals sine of c over c. So we always set it up this way, kind of like similar triangles in the sense that we were setting up the corresponding side length ratios, but we're just using similar triangles here. Or, sorry, we're using the sine law here. Woo! Now what we're going to do here is substitute the values that we know. And see here, it's pretty important that you know that this is side A, right? And this is side B. So what we're going to do is fill in the values here. Whoops. We have here sine of A over 23 equals sine of 36 over 16, which equals sine of C over C. Now, remember, we need the one completed ratio to be able to solve, and that's the one that's right here. We love this one, and we probably saw it coming from the very beginning because we saw angle B and side B. Now, the next part of this that I haven't really read in great detail, but it is extremely important here, is that we need another ratio with only one unknown. So if you look at the remaining two ratios, look, sine C over C has got two unknowns, so we can't actually use that for much here. And if you look at the ratio A, we have sine A over 23, and that's the only unknown, so we're quite happy about that. So what we're going to be able to do is solve for angle A first. So you may want to put a title, solve for angle A. Or you could just put capital A, because we do know that capital A means angle A. So what we're going to do is set the ratio with angle A equal to the ratio that is complete. And at this point here, what we want to do is isolate for sine of A, and we're going to do that by multiplying each side of the ratio, or each side of the equation, by 23. This denominator here of 23. So we're basically multiplying this side by 23 and multiplying that side by 23. I don't know why I did it with the old school times symbol, but we should be using brackets here. The timesing 23 cancels with the dividing 23, and what we're left with is the sine of A equals sine 36 divided by 16 times 23. Now, you're able to go into your calculator and type that in. So open bracket, sine 36 divided by 16, close the bracket. Now, have another look in there in your calculator. You want to do sine of 36, and if the 36 is in a bracket, like if your calculator opens up and says, you know, I'm going to write down here, if your calculator opens up sine like that, when you type in 36, don't forget to close that bracket off, then put divide by 16. Otherwise, your calculator is going to think that you want to do the sine of the angle 36 divided by 16, and that's not what we want. We want the sine of angle 36, and we want to take that result and divide it by 16. So that can be a little bit tricky. So when you are doing this, be careful using your calculator. So in our calculator, we have open bracket sine of 36 divided by 16, close all of that off, open up a new bracket, 23, and we press equals, and what we get is this nasty long decimal that might be familiar from 8.1. We get sine A equals 0.8449413,002. Now, what we remember from 8.1 is that I often told you to use 4 decimal places. Always the 4 decimal places when we're dealing with the trigonometric ratios. Now, we're solving for angle A. And as you might recall from 8.2, which is SOHCAHTOA, whenever we're solving for an angle, we're going to be using that inverse button. So what we're going to do here is solve for A, angle A, by using the sine inverse of that decimal. So we're going to go to our calculator, shift sine 0.8449, close the bracket, press equals, and we should get 57.66, meaning 57.7 degrees. And it is an angle, so we should put degrees. So we're going to go to our beautiful diagram over here. 57.7 degrees. How do I put a degree here? Maybe something like that. Sure. Great. Oh, it's 0.7. Whoops. 57.7 degrees. And that's for angle A up there. Now, at this point, you might think we're doomed because we don't have this third ratio here to solve for the third angle, which is angle C. But don't forget that the sum of the interior angles of a triangle add up to 180. So that must mean that angle C equals 180, take away angle A, take away angle B. So we sub in our values for angle A and angle B. We have 180 minus 57.7 minus 36. And please use a calculator here. And we press equals. And you should get approximately 86.3 degrees. Okay, so folks, that seems to be it. There's some homework here at the bottom. And you can also find the homework on the unit outline at the front of your notes package. But I do want to leave you with one piece of advice that we often run into in some of these sine law questions, maybe in the homework or maybe on a quiz or something like that. And the piece of advice is this. Let's just pretend we have some random triangle like this. Yeah. We'll call it triangle ABC, as we always do for whatever reason. And how about this? We'll say this is 30 degrees, okay? We'll say this looks a little bit bigger than that, so perhaps we can say this is 40 degrees, okay? And then we'll say that this side here is 15 meters, okay? Something like that. And then the question might say something like, solve for side length B. Okay, we'll put question here. Whoops. Question. Solve for B. And in this situation here, we're thinking to ourselves, oh, we're solving for side B. So we're going to use the sine law where the angles are, or sorry, when the sides are on top. So that means A over sine of A, which means B over sine of B, which equals C over sine of C. And then, if you're following the note, they often tell us, okay, let's set up the usable, let's substitute the values that we know into the equation. So we know this is little a, we know this is little b, we know this is little c, like that. Angle B, angle C, and angle A, right? So let's go ahead here. We have 15 over sine of A. And then we have B over sine of 40. And then we have C over sine of 30. And, you know, we are solving for side B, so we need to use that ratio there. And then it's like, if you look at the other two ratios, we have an unknown angle A, okay, that doesn't help us. And we have an unknown side length C, which doesn't help us. And it might feel like at this point this question seems impossible. However, it is totally, totally possible. Whenever you run into a non-right angle triangle problem, and if you look at this triangle, we have 2 out of 3 angles. What that means is we can solve for angle A quite simply. We can do 180 minus 30 minus 40. And then A equals, I think it's 110, but I'm going to double check here. Yeah, 110 degrees. So A is really 110, and the question didn't really tell us that. So we got to go back down here and sub in 110, and now we have this completed ratio for us to love and use and solve for side length B. That's the last piece of advice I think that is useful. So again, whenever you have 2 angles in any triangle, solve for that third one because it can actually be super, super useful at some point. So folks, the homework is here. If you might have any questions, please let me know. But other than that, take care. Enjoy.